what can we see? All right, what can we see? Let's just close this. Let's just increase that and let's make some observations. Some very important observations. Some very important observations. Observation number 1. So just voice out what you were saying. All right.
So what are you saying?
Yeah, whatever that's in your
So I
mind.
got you something. I don't know if it makes sense. So
Whatever
in
you
my
say,
mind,
trust me,
I
when
thinking
you're doing that,
now.
whatever you say making sense. Whatever you say
Okay.
makes a lot of
So
sense.
whatever my brain's thinking is that you see that X you put there, that 18 centimeter, that is our Y value because that's the rate at which it increases.
So you say 18 centimeters
That's
is the what?
our Y value.
Someone else is the rate, all right?
That's our gradient. Sorry, that's our
Right,
gradient at which
right, the rate,
it.
gradient, all right? And what can we say about that? It's every week, right? It's
Every
it
week.
grows. The word grow implies what?
An increase in
Increase,
that
right?
one unit there.
Increase of how much? 18 every week, isn't that so?
Every 1 week.
So that's the definition of gradient right there, isn't that so? Yeah, that's our M, isn't that so? That's our M, you know. Now I heard somebody say something else. They were talking about variables. Remember, you have Y is equal to MX plus C. M is a number, C is a number, but Y and X are variables. Can we identify the Y there and the X just by that little piece of information? Before we read further, I can see a Y and an X there. What would be the Y? Y would be what?
1 week.
X would be what?
For 5 centimeters would be Y.
Let's go back to the one we had a while ago. In this example, Y was volume and X was time, isn't that so?
So the initial thing would be 5 centimeters.
Y was volume and
Okay,
X
so
was
Y
time. So we don't coming down there yet, you know, just there alone. So Y looking like height, isn't that so? Grow.
Yes, sir.
All right. And what would be X there?
The week.
X would be the week. Is the week
Yes,
a variable?
the 1 unit.
Height is a variable. And what is the unit for that height? Height could be in meters, kilometers. What's the unit?
Centimeters.
Centimeters. Now, when it comes to there now, somebody said week. Week is a valid word there, but what is week here? Week is, right. When you go to Y, height is the variable and centimeters is the unit. So you have the variable. Variable is height. And the unit is centimeters. The variable is height. Right? And that would be the Y. Now, when comes here now, what would be week?
7.
In terms of that language, Y variable, the height is the variable, the unit is centimeters.
X. The independent variable, the time.
Independent variable. Independent.
Yes, the independent variable.
And what is the independent variable?
The time, the week.
The time of the week.
The week.
Uh-huh.
Then the week is not the time now would be the 1 unit on the x-axis.
Oh, we're talking well, I using unit there in a different way. You see, like height have different units, you know, like centimeters, kilometers. So that's how I'm using the word unit there. Okay, the variable is time. And the unit now is week. Because time can be in weeks. What else time can be in?
Days, months, years.
Exactly. Okay. So the variable there is actually time. Okay. And week now is like how it is measured. It is measured in weeks. Okay. So week is not the variable. You have to try to make that distinction. Centimeters is not the variable. Centimeters is the unit for that variable height. It could be kilometers, it could be miles, it could be inches, all right, millimeters, whatever. Week could be days, it could be years. Time is the variable, the independent variable. So all that information can be gathered just by those 1, 2, 3, 4 words, okay, and a number. So having established that clear, okay, we can now move on and see. At the start of the week, the plant was 5 centimeters high. At the start of the week, how can we interpret that 5 centimeters? Anybody?
The
So would you
initial
say
height.
initial height?
Initial height. Initial height. So in terms of y is equal to mx plus c, it will be the what? That 5 will be the what? 5 will be the c, isn't that so? The initial height. So 18 is the gradient m. Okay, 18 is the gradient m. And 5 looking like it is the c, it is the initial. Okay, 5 centimeters is the initial. Right, the word initial is very important. Let's put it in bold. Initial height, and then that would be C. All right, the y-intercept. Okay. So therefore, we have the M and we have the C. We cannot say nothing much about the 5, right? 5 is the C. What else can we say about the initial? Let's mention the word 0 somewhere. This is the height when what? When dash is equal to dash. Can somebody please tell me?
5 centimeter is the 5 centi. This is the height when 5 centimeters equal to 1. I don't know.
When 5 centimeters equal to 1?
Equal to 1 week.
Anybody else?
Or 1 week is equal to, I don't know. Because if you say the initial is 5 centimeters, so that is it 5 centimeters in 1 week.
And then no, 1. You cannot associate the word initial with 1. Remember what we said? Whenever you see the word initial, what must comes in mind? It right there.
Initial implies that the time is equal to 0.
What is equal to 0? What it is equal to 0?
The initial
height.
The initial height equal to 0?
Initial.
But look, it is written there, you know. The term initial implies that
the time.
The time.
Time is 0.
The time. And the time now is the independent variable. It is the x. Okay, the independent variable. Right? Remember, it's 0, c, you know, isn't that so? It's 0, c. Remember the 0, c. Look at that. The 0, c. Okay. Time is x. So when you hear initial, think of 0, and who is 0? X is 0.